Um, the borrow function is one of the functions that relies on an oracle because when a person wants to borrow, we have to know the asset they're borrowing against. So in this our model, a person doesn't borrow against the value of their entire like collateral assets. In this instance, they're borrowing against the value of one, so it's a one for one. You know, I would say the argument is that it's safer for the user because if we borrow against all the pool of your assets, then the protocol can just go and liquidate all your like loans and then you really lose a lot of money. So this way we isolate the borrower. Okay. We can maybe maybe I can decide in future to make the borrower not isolated. I can make it like a cross borrow and in which case a person may lose more, you know. But at the moment, for simplicity, we're just going to make it a simple borrow. So one thing that we need for this borrow is we need an oracle. So what's an oracle? An oracle is basically something that gets the price of an asset from like from a maybe like a real world or something. So let's create our oracle contract. So we're going to call this called mock oracle. So we'll create a mock oracle.sol. We're also going to create something called an interface for it so that we can reuse the interface. iMock oracle. So let's copy our standard text, and this is for interface. So we'll call this an interface iMock oracle. Okay, boom. And then for the other guy, this is the contract. So we say contract is iMock oracle. Okay, all right, cool. Sorry, no, contract is mock oracle, not iMock oracle. Okay, so I stands for interface. Let us import iMock oracle from here. Okay, and then when we import it, let's link these two together. You've seen me do this before, all right? So the two of them are connected. Now we've linked them. So we're gonna write a function. So when you write a function there, we also have to write it here because they're connected, all right? Because the interface has the function. Unlike when you inherit a contract, you don't need to write the function. It's like here, I inherited an ERC4626. Where is it? Here, and I didn't have to write. I didn't have to write deposits. I didn't have to write withdraw. It came with it. But for when you inherit an interface, because an interface doesn't have like an implementation, you have to write the implementation. So here, the interface that I am looking at right now is I want something to set a price. So function set asset price. So set asset price needs two things. One, the address of the asset. All right, and then two is the price. In 256 asset price. Okay, all right, cool. External done. We also need a function to get asset price. So why are we doing this? We're doing this because we need to be able to mock the behavior of how an oracle is going to behave. When I'm not going to write the oracle function now. I'm going to use the interface, but I'm going to show you how to write it afterwards. Okay, so address assets. Okay, and then external view returns uint 256. So basically, whatever price we set, we can get it back. All right, so let's copy this because we need to do the implementation here. Otherwise, this tells you an error. So what you're going to do is we're going to do this. That's okay. And just leave it at that. All right. Now, we are also going to import this iMock oracle. We're not going to import this one. We're going to import iMock oracle into our market. So let's get imports iMock oracle from what we've previously written. Okay, because this is like a shell. This is like a shell. If you import this, it's going to be like you're adding even more code within your code. So this is cheaper to import than this. Okay, and they technically do the same thing. All right. There are other ways to use an interface, but this is the one that I think you should use while you're getting used to it. Yeah. So let's go to the market. We have the iMark Oracle. So what we're going to do now is the very first thing is where is the borrow? Okay. When you're doing borrow, you need to do your address check. Okay. So this is how it works. A person says, I want to borrow against this asset. Let's check that the address is not like nonsense. Yeah, it's a real address. So we check collateral token address. Okay. All right. Cool. Done. Next thing we want to check is we want to check if the value of the asset is something that can cover, right? So I think we wrote a function to estimate calculate price times quantity, which is what we're going to use now. So first thing is let's get the price. So int 256 asset price. We get it from using iMark Oracle. Sorry. Okay. And then remember iMark Oracle. We need the Oracle's address. Where do I get the address from? I need an address for the iMark Oracle, because if you're going to call an Oracle, this is not enough for you to have like the it's not enough for you to have the interface. You need to have the address. So the interface is like a general instance. The address is the specific instance. So we need a way to narrow it down. So that means we need this address of this mock Oracle contract to exist within market. So in order for it to exist within market, we need to be able to set it. Okay, so to set it, we need to write a setter function for it. So this is not an internal function. This is like a proper function. So let's say function set Oracle address. Okay, then you put the address here, and you say Oracle. So you see why I'm going to use this Oracle, and here. So I need an Oracle that I can set in storage, right? So let's come to global. These are all my UN256. Let me see, I don't have any address types, so let me put my address types here. So address public, so that I can view it as well if I wanted to. Oracle. Okay, so now we're going to set this value. Let's go in. So this would then be, first of all, run your address check. Cannot be. Okay, and then next thing is Oracle should be equal to Oracle. Okay, so now we have access to Oracle. So that means that when we're setting up our contracts, we need to make sure that this is set. Okay. I mean, another way we can do it is you can also set it in the constructor here. All right, but I don't want to, pass in another value here. It's going to be too messy for me. So what I'm just going to do is, given that we've already set this, I can come here and call Oracle. Okay, and then I can say the Oracle. I know mock Oracle has two functions. For some weird reason, it's not saying get asset price, but that's fine. Call get asset price on it, and it says here that it takes in an address. Yes, collateral token address. Okay, and then boom, so we have the asset price. Okay, and we want the UN256 assets, so available assets quantity is this just made me realize that sometimes when the person borrows, we need to reduce the quantity of what they have borrowed and increment another quantity. So think about it this way: someone borrowed, maybe they have 1,000, but they borrowed against maybe 100. They still have other assets that they can still borrow against in the future, right? So we need to think about that. What we are going to do to handle that scenario is we need to come to here, and we need to add something called, so this is the borrower's asset that they currently have. So the two things we need to track, I think, is we need to track borrower asset available, and we need to track borrower asset loaned. Sorry, the quantity loaned. Yeah, because when a person is borrowing, that amount is the quantity loaned, and when we take from that amount, this value should reduce. All right, this value should reduce while that value increases. When they pay back, that value goes to zero, and this value increases. Yeah, so let's call this borrower asset available. Okay, this creates an error somewhere here. Let's just fix this error. Okay, I need to maybe comment this out so I can see things clearly. Okay, now we've called this borrower asset available. So we have another type of it that's similar to it, just a clone, but this one is borrowed. Let's call it borrowed. Okay, good. So they're identical, but we'll just call it borrowed. Okay. Now, yeah. So the first thing is we want to check the available asset quantity. So the available asset quantity is we look into borrower info with the borrower's address. We look into asset available, all right, and when we call this, we also need to, because borrower asset available is an address to amount, so we need to pass in the address index, so that would be collateral token address. Okay, so that's the available quantity. All right, so asset price, asset quantity. Now a borrow is only acceptable if the amount, okay, so let's get the borrowable balance. Okay, I think I wrote something called can borrow here. Where is it? Can't find it. It's fine. So we know what the, so imagine here a person's asset price is like 20, and then they have maybe 50 here. So we know that the total value that they have is like 1,000. So the first thing is, like, if the total assets value is 1,000, then we need to make sure that the amount that they are borrowing is less than the loan to value ratio of the product of asset price and quantity. So what we need is we need amount to be less than the product. We need amount to be less than the loan to value ratio of less than or equal to the loan to value ratio of price times quantity. Why is that? For obvious reasons. Like I said, if this is 20 and this is 50, this is 1,000, and the loan to value ratio for this asset, let's assume it's like 50%. That means you can only borrow like 500. So this amount must be less than or equal to 500. Otherwise, you can't borrow, right? So do we have a loan to value in the global? Yes, we do have a loan to value ratio, and the loan to value ratio is something that I think we should have a setup for. Where is it set? Let's check. I'm going to search this. We use it here. Okay, yeah, we have a set loan to value ratio. That's cool. So that's where it's set. All right. So we need to make sure that so the loan to value ratio is usually a number between where is it? So it's usually a number that is between ideally, like mathematically, it's between 0 to 1. But we know that within our model, it's going to be like a value between 0 to 1. So it can be 0 0.5, 0 0.6. So if you have something like, if it's 0 0.5, this is how you represent it. It's 0 0.5 ether. This is how you present it. If it's if it's 0.75, it's 0.75 ether, that sort of thing. So that's what it should be. It should be between 0 to 1. Okay. So we come down here. All right. Now we want to know what loan to value is. Remember what I told you that when we do multiplications of big numbers, you have to divide. So first thing I want to do here is in 256, total value is equal to asset price multiplied by available asset quantity. Then we have to divide this by 1 E18. This brings it back, normalizes this. This normalizes it. So the borrowable amount, create in 256 memorable, borrowable amount is, hi guys, so here I actually cut the video and I stitched another video to it because I think that there was some stuff I should have addressed I didn't address, and I thought like there's no better time to address it than now because I changed the borrow function slightly. So when you're watching this part and you see like it skips forward to something else, it's not wrong. We go back to writing the borrow function after, but it's important that you understand this following bit because it's going to make sense. All right. Hi guys. So I'm going to deep dive some explanation into the borrow function that I'm about to write. So let's use Alice. Alice wants to borrow $250 in stablecoin, right? But we know that the loan to value ratio in this pool is 50%. So loan to value ratio is 50%, yeah? What does this mean if in terms of the value that Alice must provide in order to access 250 in loans? It means that Alice must provide 250 divided by this value of the LTV. So the idea behind this is if you have 500 with an LTV of 50, you can borrow 250. But we worked it backwards. So we said if Alice wanted 250, she has to provide 250 divided by the LTV to get the value provided. Now this establishes a relationship, a very important relationship that we're going to implement. So when a person wants to borrow, we're going to ask like how much do they want to borrow and how much value is provided. Now, if Alice doesn't have this 500, then she obviously can't access this loan, yeah? But the thing about this value is Alice has some assets, but how do we know the quantity of that asset that is equal to 500? So to get the quantity of assets needed by Alice, we need to know the price of a unit of an asset, of this asset. So what's the price? So we get the price from an article. The price of assets is let's assume the price of assets is $4.5. Okay, so the quantity of assets needed will be 500 divided by 4.5. No, I don't like this number. So I'm going to modify this slightly. No, this is a better number. Okay, so we can see that we need approximately 76.9. So that means that when we check Alice's collateral balance, if it does not have at least 76.9 tokens, then Alice cannot borrow her 250. And if it has more than 76, we only take what's required, which is 76.9 or 77. Now, this is a very important concept because it allows us to properly estimate what the borrow value is. So I'm going to be showing you something else right now. In the previous video, I showed you how we arrived at all of this, but there is a catch on the blockchain, and on the blockchain, it's the fact that there's no decimal point. We use fixed point math, and that's why we have 18 decimal places. So a number like 76.9 gets rounded down to 76. This would mean that Alice's positions will be under collateralized, and we can't have that. So in order for us to be able to get the correct amount of assets, we need to round up, right? So how do we round up, given that we're doing this? Now, this value is derived from the division of D9 and D12, okay? We're going to do a math trick here. And the math trick is that we're going to try to get this number to go up by 1. Like, we're going to push the number, and we're going to try to get the number to go up by 1. All right. And I think a very decent way to do that is, so instead of dividing by 500, we're going to divide by 500 plus the denominator minus 1, so that this entire thing is like this. Oh, come on. Plus the denominator minus 1. Do this. Do this. Do this. Yeah, good. So what did we just do? We managed to, so we incremented the value from 76 to 77. So we rounded up by 1. This way, our value here is going to be, in a sense, over collateralized. All right, this actually does protect us. So we're going to implement this, obviously, in Solidity, so that when you round down, because we lop off this number, so instead of getting 76.9, we now get 77, and the remainder gets lopped off. So you see, it's a minor improvement, but it does help us to get the actual value correctly. So we will be coding this, all right, and hopping into that in the next video. Okay, let's go.